All right, I promised people who weren't able to review with us a few notes. These are going to be kind of a random grab bag of things specific to getting ready for the AP, the AB Calculus AP in particular. I apologize for my cough that I have. The first thing, it's going to be a little weird as well. I don't have a good way to integrate the calculator display with the video, so I'm just going to have to tell you about this. It's not really rocket science, though. On the calculator part, there are many, many situations where you're going to be integrating something. Like you're going to be like integrating 1 to 3 cosine of x squared dx. Okay? If you have a definite integral that they want you to calculate, or if you can get it into the form of a definite integral, then there's a couple ways. There's two ways, at least two ways to proceed. One is you can try to anti-differentiate, do it by hand, take the antiderivative, plug in these numbers, do the usual thing. But that might be slightly difficult, very difficult, or impossible. This one I wrote down particularly because it's impossible to do this by hand. But even if it's even slightly difficult, if you're on the calculator section, it's going to be quicker to go ahead and just put it into the calculator. Okay? And I'll show you how to do that. I'll just tell you the command. It's called finint, and it's on the math menu, number 9. So just do math and then 9, or math and scroll down. But really, if you just practice math 9, 2 buttons, and it brings up finint, open parentheses, and then what you'd put in is cosine of x, then squared. And the syntax is really important to get used to. You put the function, then the variable of integration, and usually you're just going to use x for that. Even if it's like t or s or u or something like here, it's easier just to use the xt theta n button and use x here and x here. And then the lower limit, and then the upper limit. Notice, remember when we read these, this is the integral from 1 to 3. You don't read top to bottom as you usually would. You read bottom to top, and that's important here. It's the integral from 1 to 3. Then just enter, and it'll spit out a number. In this case, where is it? I calculated this guy. It's minus 0.20166, or to 3 decimal places minus 0.202. And 3 decimal places is something to really pay attention to. That's what they're looking for. And you should round, although they usually kind of will give it to you if you just truncate at 3 decimal places. But it's better off to round. And if you're doing a multi-step calculation, please leave as much accuracy as you can in intermediate calculations. You don't want to degrade your accuracy. So use things like the second answer button, or use second entry. This is the shift of the weird minus. This is the shift of enter. And that's a way to get your answer back in full accuracy on the screen. It's a way to get what you just entered, if you want to repeat it or correct it, back on the screen. But your main thing there is this tool, finint, of a function. And that's going to be really crucial on the calculator part. You're not going to encounter an AP exam where you won't use this at some point on the calculator part, either multiple choice or especially in free response. Other things you're going to be doing on the calculator would be like using on a graph. You're often going to use the second calc intersect feature to find out where two things intersect. Just grab that off the calculator. Be sure you get it to 3 or preferably 4 or 5 decimal places, and those might actually become the limits for an integral. You might have a situation where you actually do an integral, like the area between two curves, where you get some intersections, and you actually got these things off of the second calc intersect, and then maybe you have like cosine 2x minus 1 over 1 plus x squared dx. This is a good example because, in principle, we could actually find the antiderivative of this by hand. This turns into a 1/2 sine 2x. This turns into an arctangent of x. And you could write that down, but then you're going to be plugging in these nasty numbers anyway. You're going to go to the calculator at some point, and you already were using the calculator to get these things in the first place. Just finint it. a mess to put in, but just be careful putting it in, careful with your parentheses. Just finint it, and you'll be good. Okay. So that's the calculator notes I had. Another thing that's maybe a little similar is I want to briefly mention if you have the trapezoid rule with unequal subintervals. And let me just do an example of that. Suppose I have time in seconds and velocity in meters per second. And say this goes from 0, 5, 15, 30, 35. And let's say this went 2, 4, 5, 6, 4. And I want to get, suppose I want to get s of 35, my position at 35, minus s of 0. In other words, the displacement. Well, fundamental theorem tells us that's, if we knew the function v of t exactly, that would be the integral of v of t. And any one of our rules would be a good way to start with that. Well, the trapezoid rule is probably your best bet. And here, we can use the trapezoid rule, but let me just sketch this out really roughly. Maybe here's the function. I've got these unequal increments, and so we can't just use the 1, 2, 2, 1 pattern. It's like this kind of thing. But we can use the interpretation of the trapezoid rule as drawing little trapezoids. What's the area under this little trapezoid? What's the area under this guy? What's the area under this guy? What's the area under this guy? And the area of a trapezoid is the width, this kind of trapezoid, times the average height. Just how wide is it times the average height. And let me show you real quick how that's a very natural thing to do here. The first subinterval is t going from 0 to 5. The width of that is 5 seconds. And the average height is just the average of those two velocity numbers. That's actually a very reasonable thing to do, even if you've never heard of calculus. If somebody just says, I don't know how far the guy goes in the whole time. Let's just figure out how far the guy goes in the first 5 seconds. It's very reasonable to use the average of 2 and 4 as an approximate velocity for that subinterval, and just say 5 times 3 is 15 is going to be approximately how far the guy goes. That's really all that we're doing. Next subinterval is 10 seconds long. That's width, if you think of it geometrically, times the average of 4 and 5. Next subinterval is 15 seconds long, times the average of 5 and 6. And then the next subinterval, that was this guy, so the next subinterval is back to 5 seconds long, average of 6 and 4. Summing that all up is going to give you your best estimate for the total distance, or sorry, the displacement traveled. Now, if some of these were negative, that there would be a distinction between displacement and distance, remember. Here it doesn't matter because I made them all positive. Now, if the way the 1, 2, 2, 2, 1 pattern works for the trapezoid rule that we're a little more used to is if these guys all are equal, then you can combine the 4 and the 4, the 5 and the 5, the 6 and the 6. There's a common factor, and it all kind of distills into a simpler formula. Because these are not equal, you can't do that. You can't do a 1, 2, 2, 1 thing. That's something that's definitely going to work when the intervals are equal. But the AP loves to put these things on because it means that even if you've memorized a formula, you have to understand the idea and the method, and they focus on problems like that, understandably. Okay, so I think that's all the crucial things that I need to do for now.